let's look at each one of the provided tables here to determine which ones represent functions. So the first table, I see that every single pairing of x and y, and remember y and f of x are interchangeable notations here. So if it helps you, you can just call these y values. And notice that every single xy pair would result in an ordered pair that you can plot on the xy plane. And every single ordered pair that's represented here has a distinct x value. In other words, there are no points that share the same x value. And that's good because your x value is your starting point or your input. And if you start at -5 and you have a function, that means that you can start at -5 and know exactly where you're going to end up and not have a question, right? So -5 always maps to -1 and no other number according to what's given here as the rest of these ordered pairs. -5 is only mapping to one location. So if I started at -5 to get directions, I would know exactly where to go, no question mark. Same thing for 3, 5, 8, 10. They're all different x values. So now let's move on to the next one. So that one was a function. Yes. Okay, now the next one. Here we see -4 with -1, 3 with +1, 5 with 6, 7 with 8, and 16 with 14. So once again, every single pair of coordinates is mapping from one input to its individual one output. Now for this one, so that was a function, I forgot to say that. This one's a function. The third one down, -2 to -1, 2 maps to +1, 6 maps to 4, 9 maps to 7, and +2 maps to 1. Okay, so here we have an issue because the value x equals 2 will map to 2 different places for the y value. So 2 will map to y equals 1, and 2 will map to y equals, oh, it's the same point. Just kidding. So even though it almost looked like there were two separate points that had the same x value, it's actually the same point and there's no problem with that. So this one also is a function. Then the last one down here, 0 maps to -2, 3 maps to 1, 3 also maps to 6, 8 to 7, and 15 to 10. So you might have already noticed that we have two coordinates with the same x value and different y values. So now x equals 3 is mapping to y equals 1, and x equals 3 is also mapping to y equals 6. So the thing is that when somebody says start at x equals 3 and then you'll know where to go, I would go to x equals 3 and then be told, hey, you can go to y equals 1 or you can go to y equals 6. And there's no, it's like, which way do I go? Now I have a question mark. I have to make a decision of where to go. I know this is not a formal explanation of a function, but it's my way of understanding it. If this was a functional relationship, I would know exactly who my partner is. That's another way of thinking of it. If I have a monogamous functioning relationship, as most people define a healthy relationship, partners are only going to be with each other. And well, now I'm kind of starting to describe something else. It almost sounds like I'm describing a one-to-one function. And that's true. One-to-one functions are where, if you consider, let's just use the traditional model, it's easier. The wife could be X and the husband could be Y, right? So where have you ever seen in history, I mean, it's very, very uncommon that one wife could have two husbands. Just unheard of, right? So that's no bueno. That's not a function. Okay. Okay. Another way to see that this is true is to make a scatter plot. And notice that when you draw a vertical line here, there's 2 points on the same vertical line, and so it fails the vertical line test. And you could do that with any of these. You could plot the points and see if you can ever draw a vertical line that would go through more than 1 point at a time. I want to circle back to this first example up here because as I was describing monogamous relationships as a way of remembering functional relationships, this one is a function because all the x values map to unique values. However, we don't see that going the other way around. In other words, y equals 1 is mapped to by 2 different x values. So x equals 3 would map to y equals 1, and also x equals 5 would map to y equals 1. So that's okay. It's, believe it or not, it's okay if you think of the x's as sister wives. Have you guys seen that show? That's why I use this example. Wife, there's wife, singular wife. So if we have 2 sister wives mapping to 1 husband, that actually is still considered functional, which is weird. It's not socially acceptable to most people, but that is one way to remember that sister wives are okay and fully traditional monogamous relationships are okay, but it's not a function if it works where, say, one wife could have multiple husbands. So I hope that makes some sense, and that you can try doing scatter plots where you don't have to do it with Excel. I'm just using it because it's convenient and I like the way the graphics look and it's quick and easy to do. See here, I can see that none of these points are on the same vertical line. So this passes the vertical line test, VLT, okay?